Welcome to the Arduino OOP course. I am thrilled to have you here. In this journey, we are going to transform the way you write code for Arduino, moving from basic scripts to professional, scalable, and reusable object-oriented programs. This course is a step-by-step project-based guide. We won't just talk about theory. We will build a real-world project while mastering OOP concepts like classes, objects, encapsulation, and abstraction, specifically tailored for the Arduino ecosystem. By the end of this course, you will be able to write clean and readable code, package your functionalities into easy-to-use libraries, and handle complex projects by combining multiple objects without the usual headache of spaghetti code. Whether you are a hobbyist looking to organize your projects better, or a developer wanting to apply professional software engineering principles to hardware, this course is designed for you. Let's get started. Coming up next, we'll dive into the big question: why should you use OOP for Arduino? See you in lecture 01.02. Why OOP for Arduino? You might be used to the traditional functional way of writing code in the Arduino IDE. While that works for small projects, it quickly becomes a mess as your project grows. Today, we will explore why object-oriented programming is a game-changer for hardware development. In procedural programming, you often end up with global variables and long functions. When you want to add a second or third LED, you have to duplicate variables and logic, leading to what we call spaghetti code. With OOP, we treat components like real-world objects. Instead of managing pins and states manually everywhere, we create an LED object that knows how to handle itself. This makes your code reusable, much easier to read, and perfectly scalable for complex robots or IoT systems. As you can see in this comparison, while procedural is fine for a blinking light, OOP is the professional standard for anything more advanced. It separates the how it works from the what it does. Now that you know the why, let's prepare for the how. In the next lecture, 01.03, we will go through the list of materials you need for this course. To follow along with the hands-on projects in this course, you will need a few hardware components. Don't worry if you don't have everything right now, as we will start with simple setups and gradually build up to our final project. First and foremost, you need an Arduino board. I recommend the Arduino Uno as it is the most standard choice. But any Arduino-compatible board like the Nano or Mega will work perfectly fine for these OOP concepts. For our specific projects, please gather 3 LEDs, ideally red, green, and yellow for the traffic light system along with matching resistors. You will also need 2 push buttons for digital input and 1 potentiometer to practice analog data handling within our classes. And of course, ensure you have a USB cable to connect your Arduino to your computer for uploading the OOP code we are about to write. Once you have your hardware ready, we need to prepare our workspace. In the next lecture, 01.04, we will look at the software setup required for the course. See you there. Before we start coding our classes, we need to ensure our environment is ready. Modern Arduino development can be done in several ways, but for this course, we will focus on the tools that best support object-oriented programming structures. I highly recommend using the Arduino IDE version 2.0 or higher. It provides better code completion and navigation, which is incredibly helpful when working with multiple files and classes. You can download it from the official Arduino website for Windows, Mac OS, or Linux. The installation is straightforward. Once installed, make sure you have the AVR board's core updated. The Arduino AVR boards may be installed automatically when you open Arduino IDE. If you are an advanced user, you can also use Visual Studio Code with the Arduino extension, which offers even more powerful tools for managing large OOP libraries. If you see the Remove button like this, you have installed completely. If you use Mac OS, maybe you need to install additionally Xcode command line tools. If you have been a software developer for a long time, maybe your Mac has been installed it. Here is a way to install. First you choose this board. Then you click on this Verify button here. Then you will see this one. To upload, you connect the board to the Mac. Then you click on Select Board. You will see an option like this. You choose it. Now you try to upload by clicking on this button. Throughout this course, we will be creating our own libraries. Ensure you know where your Arduino/libraries folder is located on your computer, as we will be moving our custom OOP classes there in later sections. With the hardware and software ready, it's time to see the big picture. In the next lecture, 01.05, we'll go through the project overview and I'll share tips on how to get the most out of this course. In this final lecture of the introduction, we will look at the road ahead. Understanding the big picture will help you stay motivated and see exactly how each individual concept fits into the final complex system we are going to build. Our primary goal is a complete traffic light system. We will start simple by creating an LED class, then a push-button class. As we progress, we will learn how to make these objects talk to each other and eventually use a state machine to control the entire sequence smoothly. To truly master OOP, don't just watch the videos. Type the code along with me. When we finish a class, try to add a new method or change an attribute. Experimentation is the best teacher in programming. By the time we reach the end, you won't just have a traffic light. You will have a library of reusable components that you can drop into any future Arduino project, saving you hours of coding time. The introduction is over. It's time to get our hands dirty. In the next section, Lecture 02.01, we start building your very first Arduino class. See you there.